Hello students, this video we are making for you to solve question number 64 onwards, and they're all related to RC circuit. Now what is RC circuit? You have resistance, let's say R, and you have capacitor having capacitance C. So to this RC circuit, what if we apply a DC voltage, let's say E? So soon we do it, if we close the key, the current will be set up. This current will slowly increase with time, and this current is not going to be constant with time, it's going to vary with time. So let's say at some time t, this current in the circuit is I, and that moment, at that instant t, we apply Kirchhoff's law. Let's apply Kirchhoff's law, Kirchhoff's voltage law number 2. So from here to here, the change in voltage, change in potential, the change in potential will be E. Then from here to here, because I is the current flowing through it, so potential fall will be minus IR. And at some time t, the charge that has deposited here is Q, and here minus Q. Plus Q and minus Q will be the charge on the two plates. So from here to here, the potential fall will be minus Q by C. And the loop over, I can write it as 0. The sum of changes will be equal to 0. So E will be equals to IR plus Q upon C. Now you're all aware that rate at which the charge is passing through this conductor is also current. So the rate at which the charge is passing through the conductor is also the rate at which charge is depositing on the plate. So for this I can write dq upon dt. So we have got this differential equation, and solution to this differential equation is not difficult. You can simply separate the variables, take this q by c on the other side. I get E minus q upon c is equal to R into dq by dt, and taking this c cross multiply, it becomes C minus q, Ce minus q upon c, and cross multiply R with c becomes RC. So you get dq by dt is equal to C minus q divided by RC. Okay, so next step, let us rub this off now. Remember that when we say RC circuit, it means that resistance and capacitor are connected in series. So rub it now. We have to solve this equation. Let us now take this C minus q cross multiplied here, and dt cross multiplied to this position, to this place. So we will get dt upon RC equals to dq divided by Ce minus q. Now let's do the integration both sides. We know that with time the charge increases on the capacitor. So let's say from 0 to t we integrate, or if we just do it without any limits, just an indefinite integration, you get integration dt is t divided by RC, and on this side we will get log of Ce minus q, whereas the coefficient of q is minus 1, so I have to multiply that minus 1 here, and that arbitrary constant, let me write as C1. Now we know that at t is equal to 0, the capacitor was not charged. So q was 0 at t equals to 0. This is our initial condition. So let's put t0 here and q also 0. So I get 0 is equal to minus ln Ce plus C1, and C1 therefore will become plus ln Ce. So we are going to substitute this ln Ce to this position, to this place, and we get T upon RC is equal to minus ln, this is ln Ce, so I may write this as okay, let me write just like that, Ce minus Q plus ln Ce, and let's multiply minus both sides. So if I multiply minus both sides, I get this minus, I get this plus, I get this minus. And all of you should know that log x minus log y is log x upon y. So you get ln Ce minus Q divided by Ce. And here on the left hand side we are getting minus T by RC. Let us continue doing the solution, which is not important from physics point of view, but the answer is important for us, the result is important for us. So let us now rub this one. So I get log of this is equal to this much. So e raised to e is an irrational number. Its approximate value is 2.718. So ln x is equal to minus t by rc. Then x will be equals to e power minus t by rc. E power minus t by rc will be equal to this one, Ce minus q divided by Ce. So Ce cancel, 1 minus q divided by Ce, and then take this minus q by Ce on the left side and this term e power on the right side. So q divided by Ce will be equal to 1 minus e power minus t upon rc. So q will be equal to Ce into 1 minus e power minus t by rc. So you can see here I am getting equation for charge, and this equation tells us that as time increases the charge also increases, and if you put t infinity here, if you put t tends to infinity, your q, you can see e power minus infinity tends to 0. So therefore 1 minus 0 is 1, 1 into Ce will be Ce. So q will be tending towards Ce. So if I plot this graph of q versus t, if I plot q versus t at t is equal to 0, q is 0, but as time increases, the charge increases, and the graph will, the rate at which it increases will decrease, and there's a limit beyond which the value of q cannot increase, or you can say the value of q gets closer and closer to Ce. So this value of charge C into E is what your q keeps increasing like this. Now if I want to know what is the current at time t, I just have to take dq by dt. So taking dq by dt, C is constant and 1 is constant, its derivative will be 0, and the derivative of e power minus t by rc, minus of this is minus, and the derivative of minus t by rc will be minus 1 by rc. So minus minus will become plus. So what we will get, we are going to get Cc cancel, and we are going to get E divided by R, e power minus t upon rc, and dq by dt, as we remember, is a current. Often author writes small I for current because it's a variable current. It doesn't remain constant with time, it changes with time. And from this graph, from this I also, you can see the value of I, the exponential function it is, again e raised to minus t by rc. The current, instead of increasing, we expect that the current charge is increasing, but the current will decrease, and ultimately it will become 0. As t tends to infinity, current will become 0. So you can see that the charge increases, and as the charge increases, the current decreases. Ultimately, current will become 0, and your capacitor will be fully charged. You can say at after a long time, the resistance will have 0 current, it will have 0 current, it will have 0 current, but the charge will become plus CE and minus CE. And this is something special here. You can see this power T upon this RC. RC is said to be time constant. इसको कहते हैं time constant. Remember, e raised to anything must be unitless. So T upon RC must be unitless. The unit of T is seconds. RC must also be seconds. So it is a its unit is time, is that of time, and if you have, let's say, 5 time constants, 5 times, it's often written as tau. So if you have 5 time constant, it is somewhere, steady, somewhere steady situation. The situation you can assume as nearly that of infinity time. Okay, 5 times time constant is quite near to infinity. When we say quite near, so it must be somewhere 90% or so. That of CE will be the charge, and also the current will be nearly 0. Thank you.